Probability, fantastic. It's definitely the hardest unit that we do. So you just have to go about the problem. Rely on just making sure you're thinking logically. You have the whole formula sheet. Make sure you are looking at that. I would suggest using your formula sheet that I gave you as the booklet and start writing on them what they're for. I know on our practice exam, I forgot to check for a binomial distribution. So we need to make sure that we're refreshing our memory on those types of things and doing the appropriate methods. Okay, so remember we could do the probability of and, which is when we multiply the probability of A and B is the probability of A times the probability of B. It's called the intersection. And remember, that's the upside down U. Or we add, and that we use the normal U, which is called a union. And then we also have the probability of A given B, and there's also a formula down below to figure that out. I like tree diagrams and Venn diagrams to help me figure out some of these probabilities. Don't forget we have what's called independent events, where they are independent of each other, so they don't change the outcome of each other. And remember, to prove independence, we have to show that the probability of A is equal to the probability of A, given that we know that B already occurred. Mutually exclusive are events that can't happen at the same time. To prove mutually exclusive, holy bucket, we have to show that the intersection is 0. So the probability of A and B has to be 0. Here are some of the formulas from our formula sheet. So they don't have the word probability of A or B, but they use the intersection and the union to show those. So remember, probability of A and B, we multiply. For or, we add, but remember we have to subtract any overlap. This is the probability of A given B. This is expected counts. So if we have certain number of things that happen and the probability of them happening, we multiply those together and add them up. This is the formula for variance. Most of the time we're going to use our calculator though to calculate variance. This next part is for a binomial distribution. Remember, for a binomial, there's two possible outcomes. It's either a success or a failure. P is the probability of success, and the book, remember, uses 1 minus P for the probability of failure, but we talked about I like to use Q. So binomial distribution, we would definitely use our calculator to find that, but then remember the mean of X is N times P. The standard deviation of X is the square root of N times P times Q. They also included the sampling distribution for P hat. I added in the sampling distribution for X bar. So remember, the mean of P hat is equal to P when we have a sampling distribution. If you remember, a sampling distribution is when we take every possible sample of size N and figure out the mean, the spread, all of that for it. We can describe a sampling distribution as well. Here's the mean and the standard deviation, the center and the spread that we would use for those. So we have the mean for P hat and the sampling distribution for P hat and the sampling distribution for X bar. And again, all of these formulas are on your formula sheet. Okay, so for in this video, I am going to start with the 2002 exam questions. The number of sweatshirts a vendor sells daily has the following probability distribution. If each sweatshirt sells for $25, what's the expected daily total dollar amount taken in by the vendor for the sale of sweatshirts? Well, first I'm going to find out the expected value, the expected profit. So to do that, I'm going to take 0 times 0.3, 1 times 0.2, 2 times 0.3, plus 3 times 0.1, plus 4 times 0.08, plus 5 times 0.02. So my expected count comes out to $1.50 or 1.52. Okay, so the expected number of sweatshirts that this vendor is going to sell is 1.52. So to find expected daily total dollar amount taken, we'll take the $25 per sweatshirt and we'll multiply it by the expected number of shirts that we're going to sell. So his expected daily total dollar amount taken in from sweatshirts would be $38. Number 23, which of the following statements is true for 2 events, each with a probability of greater than 0? So if the events are mutually exclusive, they have to be independent. That's not true. If they're mutually exclusive, they do not have to be independent. Remember, independent means that they don't change the outcome of each other. Mutually exclusive just means they can't happen at the same time. So we could have one and not the other. If the events are independent, they must be mutually exclusive. Again, no, that doesn't mean that they have to be mutually exclusive. If the events are not mutually exclusive, they must be independent. Again, no, they are not, they don't really have a correlation. If the events are not independent, they must be mutually exclusive. No. If the events are mutually exclusive, they cannot be independent. So if they are mutually exclusive, which means they don't happen at the same time, that means that they can't be independent of each other. Number 32, in a carnival game, a person can win a prize by guessing which one of the 5 identical boxes contain a prize. After each guess, if the prize has been won, a new prize is randomly placed in one of the 5 boxes. If the prize has not been won, then the prize is again randomly placed in one of the 5 boxes. If a person makes 4 guesses, what's the probability that the person will win exactly 2 times? So we want to know what's the probability that x is equal to 2. Well, this is a binomial distribution because there's a chance that they're going to win or there's a chance that they don't. So there's either a win or a fail, a success or a fail. So in this case, P is 1/5, which is 0.2. That's the probability of a success. The probability of a failure then is 4 out of 5. So remember, go back to your formula sheet. If you look at the formula sheet for a binomial distribution, this would be our formula. You could also figure all of these out, but because you have the formula sheet, and if you start labeling them and studying the formula sheet, I think that would be the easiest way to determine. Number 36, an urn contains exactly 3 balls numbered 1, 2, and 3. Random samples of 2 balls are drawn from the urn with replacement. The average, x bar, where x1 and x2 are the numbers on the selected balls, are recorded after each drawing. Which of the following describes the sampling distribution of x? Okay, so when we're doing this, first we are going to draw 2 balls. Then we can find the average of those 2. So notice it said with replacement. So the possibilities, I could have a 1 and a 1, a 1 and a 2, a 1 and then a 3. I could have a 2 and a 1, a 2 and a 2, a 2 and a 3. And we could have a 3 and a 1, 3 and a 2, and a 3 and a 3. So I find the average of each of these. The average here is 1. This is 1.5. This is 2. 2 and 1 is 1.5. 2 and 2 is going to be a 2. This is going to be a 2.5. This is going to be a 2, 2.5, and a 3. So then I'm going to list these. 1, 1.5, 2, 2.5, and 3. And I'll tally it. So how many times does a 1 occur? Once. 1.5 occurs twice. 2 occurs 3 times. 2.5 occurs twice. And 3 occurs once. So there are a total of 9 outcomes. 1 plus 2 is 3, plus another 3 is 6, plus another 3 is 9. So we're looking for a tally. This would be 1 out of 9, 2 out of 9, 3 out of 9, which is 1/3, 2 out of 9, and 1 out of 9. So the one that matches with that would be letter B. Okay, next we are going over to 2011, number 2. The table below shows the political party registration by gender of all 500 registered voters in Franklin Township. Given that a randomly selected registered voter is a male, what's the probability that he is registered for party Y? So, probability of Y, given that we know he's male. So if we follow the formula from our formula sheet, which I would just get in the habit of doing, it's the probability of A and B divided by the probability of B. So in our problem, it's the probability of Y and male divided by the probability of being a male. So Y and male, 48 out of males, 200, which reduces to 0.24. Now, if you did it with the rule, it would be 48 out of 500. Males would be a total of 200 out of 500. But that reduces to 48 out of 200. Letter B says, among the registered voters in Franklin Townships, are the events is a male and is registered for party Y independent. Okay, so remember, to prove independence, we have to show the probability of Y, given that it's male, is equal to as the probability of being male, given that they were Y. So the probability of Y given male we found was 0.24. For this one, we would have the probability of male and Y over the probability of being Y. Male and Y, which we know is 48 people. For probability of Y being party Y, it's 168. And 48 divided by 168 is 0.28. So since they don't equal, they are not independent, which we should write that. Okay, so hopefully you've also read the Chapter 9 packet that I gave you as help, and also hopefully you are also started reading Chapter 10 from that packet, and I'm hoping that that will help you get through the rest of this packet.